Next topic is prevention of rust. So the wasting or the rusting of iron objects, a big loss to the industry, means to the country, economy. So it must be prevented. So we have to use several methods. We have to use several methods to prevent the rusting of iron objects. Most of the methods involving coating the iron objects with something to keep out air and water. So what are the methods we have to use to prevent the rusting? So the general method we have to use is painting. Applying oil or grease, then galvanization, electroplating and alloying. So general methods you have to use to reduce or prevent the iron of rusting. So painting, rusting of iron by applying grease or oil, galvanization, then electroplating and making alloys. So painting, this is the general method we have to use in our day-to-day life. When we apply the paint on the iron objects, so the thin layer is prevent the rusting of iron, because the air and the moisture cannot come in contact with the iron, so no rusting takes place. So the iron articles such as window grills, railings, steel furniture, iron pipes, iron bridges, railway coaches, ships and bodies of car and buses and trucks extra are painted because of to prevent the rusting of iron, gentlemen. Then coming to the applying oil or grease. When we apply the oil and grease on the iron objects, so that layer of oil or grease reduces or prevent the rust of iron. Rusting of iron can be prevented by galvanization. So what is meant by the galvanization? So the process of depositing a thin layer of zinc. The process of depositing a thin layer of zinc on iron objects is called as galvanization. So galvanization is done by dipping an iron objects the molten zinc metal. So then what will happen? A thin layer of zinc is formed in the iron objects. So zinc reacts with atmospheric oxygen and form a thin layer. So a thin layer of zinc metal is formed all over the iron object. This thin layer of zinc metal surface of iron object protect them from rusting, because of zinc metal does not corrode on exposure to damp air. So zinc cannot react with the damp air, so no corrosion takes place. So the iron sheets used for making buckets, drums, dustbins and sheets are galvanized to prevent their rusting. The iron pipes used for water supply are also galvanized to prevent the rust. So a thin layer of zinc is formed, giving a thin layer of zinc on iron objects. It protects from the corrosion. How a more reactive metal, zinc, is able to protect the iron from rusting. Generally, more reactive elements are highly reactive with atmospheric conditions and oxygen. But how these are protect, how the zinc is protect the iron from rust. So the action of air or a zinc metal forms a very thin coating of zinc oxide. Zinc oxide. So if it is considered any iron object, if any layer, if we made a thin layer of zinc, so this zinc is react with the oxygen and forms zinc oxide. This zinc oxide coating is hard and impervious to air and hence prevents the further corrosion. So iron objects, the zinc oxide coating form on its surface protect the zinc metal of zinc oxide layer as well the iron below. So a layer, the outside layer is react with oxygen, forms zinc oxide. Zinc oxide. This zinc oxide prevent the further corrosion of zinc and under the zinc layer is iron objects. So iron also cannot rust. So the galvanized iron objects remains protected against rusting even if a break occurs in the zinc layer. If it is any break happen in the zinc layer, but there is no corrosion, there is no further corrosion of iron objects. Then electroplating. So the coating, the process of giving or giving a coating, giving a coating of one metal, especially high reactive metal, coating of one metal over the another metal by the process, by electrolysis is called. So I have inferior metal, superior metal over the another metal in the sense inferior metal. Superior. So the coating of superior metal on the inferior metal by the process of electrolysis. Is called electroplating. So in class 8, in chemical effects of electric current chapter, so you already learnt about the electroplating. So maybe in your school the activity is performed by the students. So in my school where I am working, so I perform this activity with the students. So maybe you have an idea about the electroplating. In this electroplating process, highly reactive metal is coated on the low reactive metal. So highly reactive metal made as a anode, then low reactive metal made as a cathode. Inferior metal and superior metal. Superior metal is the metal which does not corrode easily. Inferior metal is the metal which corrode easily. So in case of copper and copper plating, so if you take copper as anode, then any iron object as a cathode, this is the reaction happening in electroplating. So copper coating, this is the anode and this is the cathode. So this is superior metal and this is the inferior metal. So most of the iron objects are electroplated by the process of electroplating with chromium and tin and chromium. So the tap made of steel has been chromium plated. Then tiffin boxes, food storing utensils are made with tin made with tin. So by using electroplating also we have to prevent the rusting of iron. Then the fifth method is rusting of iron can be prevented by alloying to make it stainless steel. When iron is alloyed with chromium and nickel, when alloying is combination or mixing of two or more metals, alloying. The process of mixing of iron with nickel, chromium, or other substance you can call carbon, coke. So used to prevent the rusting, and they form as steel or the stainless steel by alloying. When the iron is mixed with the another metals, so we can prevent the rusting of iron. So these are the 5 methods. These are the 5 methods used to prevent the rusting of iron. So general topic only, then you are able to understand well. No problem. Then one pillar in Delhi, iron pillar in Delhi, right? The iron pillar of Delhi is wonder of ancient Indian metallurgy. So the iron pillar at Delhi was made more than 2000 years ago. It has not rusted all. So this is really a wonder. So we really appreciate our Indian metallurgical that those kind of technology, what methods they have to use. So the iron pillar near Qutub Minar in Delhi is made up of wrought iron. So which is low carbon steel. This iron pillar was made around 400 BC by the Indian iron workers. Though wrought iron rusts slowly with the time, but Indian iron works had developed a process which prevented the wrought pillar from rusting even after thousands of years. So this is the greatness of our Indians. So really appreciable thing. Then alloys. The last topic of the chapter is alloys. So just now we discussed what is meant by the alloy. What is meant by alloy? Let's understand alloys. The various properties of metals like malleability, ductility, strength, hardness, resistance to corrosion can be improved by mixing other metals with it. This mixture of two or more metals is called an alloy. The mixture of two or more metals. The mixture of two or more metals are called alloys. So this alloy also prevent the rusting. So aluminium metal is light but strong, but an alloy of aluminium with copper, magnesium and manganese called duralumin is a mixture of aluminium plus magnesium plus manganese. So the mixture, aluminum is light in weight and but strong. So when it is mixed with copper, magnesium and manganese, then the alloy is called as duralumin. So plus copper also is called as duralumin. So as well as strong. Since duralumin is light and yet strong, it is used for making the aircraft bodies and parts, space shuttles, kitchenwares like pressure cookers, etc. Similarly, aluminium is light but not hard, but an alloy of aluminium with magnesium, only with magnesium, can call magnalim, Magnaline. Magnaline is a mixture of aluminium plus magnesium. Duralumin is a mixture of aluminium, magnesium, manganese and copper, whereas the Magnaline is a mixture of aluminium and magnesium. Aluminum and magnesium used to make balance beams and light instruments. Alloys have properties which are too different from the constituent metals. In fact, it is possible to make alloys having required properties. In some alloys, however, non-metals like carbon also present. This will become more clear. Right? So finally, here observe that two or more, mixture of two or more metals. Here two metals, aluminium plus magnesium, Magnaline. So duralumin, aluminium, magnesium, manganese and copper. So these two are the examples. These two are the examples for alloys, and aluminium playing very important role. Right. So these all are the metals, but we have some of the non-metals. Some of the non-metals also present in the alloys. So for example, steel. Steel is the combination of iron plus carbon. So it is a non-metal. So coke. So iron plus carbon. Whereas stainless steel is a combination of iron, nickel, carbon. And carbon is a stainless steel. So when iron metal is allowed with such as chromium and nickel plus chrome, the combination of iron, nickel, chromium and a non-metal. So iron, nickel, chromium are the metals, whereas the carbon is a non-metal, even though a mixture is formed. So this is also called as an alloy. So iron plus carbon is steel, iron plus nickel plus carbon plus chromium is a stainless steel. These stainless steels we are using for many purposes. An alloy is a homogeneous mixture of two or more metals. So homogeneous mixture and heterogeneous mixture you already learnt in class 3. An alloy is prepared by mixing. How these alloys are formed? So these alloys are formed by various metals in a molten state. In a required proportions, and then cooling their mixture to the room temperature. As we know, metals having high melting points and the boiling points. So when the metals are heated at certain temperature towards the melting point, then they melt. So the melted form of metals are mixed with the proper proportions, proper quantities, and they cools down. Then an alloy is formed. So this the form. The properties of an alloy are different from the properties of constituent metals. So iron has different properties, then carbon has different properties. Iron, nickel, chromium has different properties, and carbon has different properties. So the mixture, the alloy stainless steel has different property than the individual properties of metals. So what are those properties? Alloys are stronger than alloys are stronger than the metals. Alloys are harder than the constituent metals. Alloys are more resistant to corrosion. Alloys having low melting points. Alloys have low electrical conductivity. What are the properties? What are the properties of alloys? Properties of So stronger than metals. Low melting point. They have low melting point. More resistant to corrosion. More resistant to corrosion. Then one more, low electric conductivity. Low electric conductivity. So these are the properties of alloys. Stronger, harder, more resistant to corrosion, then low melting points, then low electric conductivity. Some of the common alloys are duralumin or duralium, magnesium, steel, stainless steel, brass, bronze, solder and amalgams. Solder and amalgams. So let's understand what are those. Alloys. Brass is an alloy of copper and zinc. Brass. Alloys. Brass is a combination of zinc and copper. An alloy of zinc and copper. It contains 80% of copper, 80% of copper, 20% of zinc. Brass. Brass is more malleable, more stronger than the pure copper. It is color also more golden. Brass is used for making cooking utensils, screws, nuts, bolts, wires, tubes, scientific instruments like microscopes and ornaments. Brass is also used for making vessels like flower vases and fitting like that of fancy lamps. Fancy lamps, flower vases also made by a brass. Then bronze is alloy of copper and tin. Bronze is the alloy of tin plus copper. Tin plus copper, 90% of copper, 10% of tin. So 10% of tin is used. Then solder. Solder is an alloy of lead and tin. Lead and tin. Solder. So lead and tin. Lead and tin. So 50% of lead and 50% of tin is present in solder. Amalgam. So when mercury is combined with amalgam is when mercury is combined with any other metal, we can say that amalgam. So mercury plus metal, mercury plus any other metal, we can say that amalgam. So mercury plus zinc, we can call as zinc amalgam. Can call as zinc amalgam. Sodium amalgam. Mercury, silver, tin and zinc used by the dentist for filling in teeth. Amalgam. Alloys of gold. The purity of gold is expressed in terms of carat. The purity of gold is expressed in terms of carat. So 24 carat, 22 carat, like carat means not 18 carat. Pure gold is said to be of 24 carats. So if it has 24 carat, then it is a pure gold. It is a pure gold. Pure gold is very soft, due to which is not suitable for making jewelry. 24 carat of gold is very soft, so it is not suitable for making jewelry. Gold is alloyed with a small amount of silver or copper, make it hard. So this harder alloy of gold is more suitable for making ornaments because it becomes very easy. In India, gold ornaments are usually made of 22 carat. 22 carat. So means gold or is mixed with the silver or copper for making jewelry. Gold is mixed with the copper or the silver. When we silver, then become hard. So then the gold is used for making jewelry. So in our country, we have to use 22 carat of gold for making jewelry. It means 22 parts of gold, then 2 parts of other silver or copper. Silver or copper. So this is about the alloys and methods used to prevent rust. So I hope understood. So please watch my videos regularly. So give a comment about the concepts and about the teaching, and subscribe. So inform or share my channel with your friends or the relatives. Thank you so much.